Hi all. Today let us learn about what is resistance and what is resistivity and their difference. So, as I have told in many videos that resistance is nothing but something that which blocks the flow of electrons. So, if we look at the Ohm's law once again, so what it says that just a minute. What it says is that I is proportional to V. V is voltage and I is current. It means V is proportional to I. Means the current flowing through a conductor is proportional to the voltage applied to the different to the points between which the current is flowing. Now, as I said that when there is a proportionality, there is it means there is a proportionality constant. It means V equal to R into I, and this R is resistance. It means something which we don't know what is resistance, but due to the advancement of technology over time, we got to know what is R. Now, if we describe what is R, then R is something proportional to the length of the conductor and also inversely proportional to the area or cross sectional area of the that conductor. So it means there is one more constant will be there, which is R equal to this constant will call rho L by A. So now if we put L equal to 1 and A equal to 1 in this equation, then what will happen? Then this R will become rho 1 by 1. So it means rho. So R equal to rho. Now let me show you what I was trying to tell you in a physical way. So let's say this is one conductor, right? This is dotted. So if you are watching this video, just let me know or comment me in the section that why this is dotted. Uh, this is area A1, this area, and let's say this length is L1, this length. Again, there is another conductor with a larger cross section. This area is called A2, and this is the conductor, and this is how it is. This is again dotted. Comment me why it is dotted. And this length, let's say L2. So, what will be the resistance in this case? Let's say R1 equal to rho L1 by A1. Let's say both are copper conductor. Both are copper conductor. Okay. So indeed it means the resistivity of both the elements will be same. Again R2 equal to rho L2 by A2. Okay. So here just look at it. I think from here you can actually understand the difference. This is resistance, and this unknown part is called resistivity. Resistivity. Now, how if we want to represent it um, pictorially, it is something like this. Let's say it's a cube of copper. Tell me why this line will be dotted. If you want to be an electrical engineer, you are supposed to have good understanding about drawing also. Anyway, so this is This is a cube of, let's say, 1 meter cube. Every side is 1 meter. So this is 1 meter square, and this area is 1 meter square. This portion, this area I'm talking about, this area A equal to 1 meter square, and this length equal to 1 meter, or this height also 1 meter. Every side is 1 meter, so it's a 1 meter cube. In this case, the resistance that this cube will provide will become what is a rho, is resistivity. So what it means, that when I'm talking about resistance is dependent on length as well as the area of the cross section. Um, in these two cases, just see, one resistance is R1, another resistance is R2, because they have different length and they have different cross sections. So because of different cross sections and area, the resistance of the two conductor will become different. But in case of resistivity, it is same. Why? Because the resistivity represents the unit length and unit cross sectional area. If you look at the this definition of rho, is what? Unit length and unit cross sectional area. So let me show you one more thing. As we are saying, R equal to rho L by A. So rho equal to R A by L. It means R into, what is A? A is nothing but L into L, right? So this L and L will get deducted. It will be something like R into L. So what will be the this unit of ohm, unit of resistivity? It is nothing but the unit of resistance and unit of the length. So rho equal to, I mean not rho equal to, this is the unit, this is the unit of resistivity, this is the unit of resistivity, right? Unit of resistivity, right? So one more thing we need to remember, that resistivity definitely does not depend on the length or area, but it depends on something else called temperature. So if you can remember the Ohm's law, the last part of the Ohm's law says that all the physical property and uh, the temperature will remain constant. So the rho value changes with the temperature. Now whenever we give a value to this rho, when say like copper resistivity is 1.6 into 10 to the power minus 8, this is at the rate of 20 degree centigrade. That is generally a standard practice to mention the resistivity of any material at 20 degree centigrade. And I hope this has cleared your doubt about resistance and resistivity. And I have created a comparison between resistance and resistivity in a tabular form. The definition, that opposition offered by a conductor to the flow of electric current, and it's a material. It says it's a material property. Actually, of course, it's a material property, and it is the same thing for unit dimensions. The symbol is like this R, and symbol is this rho. The unit is ohm, and here the unit is ohm meter. The formula is R equal to rho L by A. It is just reverse of that, rho equal to RA by L. And resistance depends on the material length, conductor cross sectional area, and temperature. And it is depends on the, of course, the material type. If aluminum and copper, if you compare both, the resistivity will be different. And it also depends on the temperature. as the temperature increases, the resistivity increases in case of most of the materials. And uh, resistance is material specific. No, it I means it is, of course, one part is yes, because if you change the material, the resistance will change. But within the material also, if the dimensions get changed, if the length change, if the area got changed, then the resistance will get changed. And it is an intrinsic property of the material. Changes with size, yes, it will change with size, it will, no, it will not, it is a constant only. It at a particular temperature, it changes with the temperature. Now if we want to define the resistance of a let's say copper wire, we need to give the length, and we also need to give the area, right? And in case of resistivity, we can directly say it is resistivity at the rate 20 degrees centigrade, 20 degrees centigrade,